Aptitude. Today, I'll be discussing CAT 2021 Slot 1 All Algebra questions. Algebra is very important. My name is Abhishek Leela Pandey. I'm an author, speaker, mathematician by profession. I train people for CAT and GMAT other management entrance exams for QA and VARC at iQuanta. Let's have a look at the 2021 Slot 1 QA Algebra section. So there were 5 sections, 5 questions in total, out of which the first question was on functions, then we had inequalities and modulus, then logarithms, then quadratic equations, and then sequence and series. A lot of students ask me, okay, can we ignore algebra or certain parts of algebra? I would say no. Because as you can see here, there are 5 questions from 5 different chapters of algebra. All the chapters are equally important in CAT. This is what has been happening from last few years. So do not ignore it. And more algebra is the most scoring section of quant. That is something which I believe in, and that's something which you also believe once we start the video solutions. Here comes the first question. This might look very difficult for some people who do not have mathematics in their class 12, but if I show you something over here, this will be very easy. So the question says, fx is equal to x squared plus 2x minus 15 whole upon x squared minus 7x minus 18. This is negative if and only if we have 4 options over here. And okay, now let us solve the question. So this is a fraction, isn't it? It's a function, but it's a fraction. And a fraction is negative only in 2 cases. The first case is when the numerator is positive and denominator is negative, or the other case is when the numerator is negative and denominator is positive. So this is something which everybody knows, and this is how we'll solve our question. So we have 2 possibilities, and that is why we have 2 intervals, if you can see in all the options. So one interval will get by the first case, other by the second case. Let us solve it. Now coming to the kind of expression the numerator and denominator are. They are essentially quadratic expressions. And a quadratic expression, when drawn graphically, it becomes a parabola. That is one point. The other point is, if the coefficient of x square is positive, the parabola will be upward facing. That is something which all of us know. And apart from that, the parabola will be intersecting the x-axis at the roots. So let us find out the roots. First of all, I can factorize fx as this. Fx is equal to the roots of the factors of these two will be, this will be x minus 3 multiplied by x plus 5. These will be the factors of the expression in the numerator. Now coming to the denominator, we have x squared minus 7x minus 18. 2 and 9 are the, we can see 2 and 9. Here we have minus, here we have minus, of course, one will be positive, one will be negative. This will be equal to x plus 2 multiplied by x minus 9, isn't it? It's so easy to break them up. Plus 2 minus 9 is minus 7, and plus 2 into minus 9 is minus 18. Similarly, if you look at this, minus 3 plus 5 is plus 2, which is the middle term, and then minus 3 multiplied by 5 is minus 15 is the last term. So it's very easy to break them all. Now comes the real thing. Without stressing ourselves much, we'll just draw a graph and we'll get our answer just like that. So if you look at the expression in the numerator, you can see the roots are plus 3 and minus 5. All right, I'll just mark plus 3 and minus 5 here, plus 3, and this is minus 5. Denominator, we have minus 2 and plus 9, just mark it here. Now what I want to do, I just want to draw the graph. And as I said, it will be a parabola, upward facing parabola, intersecting the x-axis at the roots. So the numerator will be something like this. And the denominator will be something like this. All right. We do not care about which point is this or this. We just have to care about under what intervals the function is negative. So the function will be negative, as I said, in 2 cases. These graphs, we have 2 graphs over here. So one should be positive, other should be negative. And if it happens, the function will be negative. Let us look at that. The first interval over here is minus 3 to plus 9. Minus 3 to plus 9. So if you look at the first graph, it is positive. It is going beyond 3. It is in the upward direction. It is a positive y. positive y-axis. So that means this graph is actually positive. And the same interval, this graph is negative. Wow, so that is our one of the intervals. 3 to 9 is the interval. Of course, 3 and 9 will not be included because at 3 and 9, the graph will be, the value of function will be 0. 0 by 0, indeterminate. So 3 to 9 is one of the intervals. Now look at other intervals. Minus 2 to 3. At minus 2 to 3, what is happening? The first graph is negative. Second is also negative. Both are negative. Negative upon negative will be positive. So of course, minus 2 to 3 would not be our answer. Then we have minus 2 to minus 5. Minus 2 to minus 5. Here, if you look at the first graph, beyond minus 2, it is positive, going towards positive y-axis. Second graph, from minus to minus 5 is negative. So positive upon negative will get negative over here. So that means minus 2 to minus 5 will be one of the intervals. If we go beyond minus 5, we can see both the graphs will be positive. So that won't be our answer, of course. And similarly, on the right-hand side, beyond 9, both will be positive. That won't be our answers. So now we have only two intervals, 3 to 9 and minus 5 to minus 2, where one is positive, other is negative, and the answer will be overall negative. So first option, if you see, it's minus 5 to minus 2 and 3 to 9. This is our answer. So easy. While explaining, I took close to 3 minutes, but if you know this and you do it on your own, you can do it mentally as well. If you draw the graphs in your mind, and you can do it in like just 20 or 30 seconds, not more than that. Well, we can solve this question in one more way, another way. So as we see that fx was equal to x minus 3 multiplied by x plus 5 whole upon x plus 2 multiplied by x minus 9. So this method involves, we don't have to draw any graph, we will just draw a number line and solve our question. So this is a number line and I'll mark all the critical points. So x minus 3 is there as a factor. So at x equal to 3, this will be 0. So I'll just mark x equal to 3 somewhere. Keeping 3 as the standard, we can mark other values. X plus 5, if you put it 0, I'll get x equal to minus 5, somewhere here. X plus 2, at x equal to minus 2, this will be 0. And at x equal to 9, this will be 0. So once we have marked this, now comes the real thing. So the best part about this is that in all the intervals, there are like, how many intervals are there? One interval is, I'll just show the intervals. One interval is beyond minus 5. Then we have minus 5 to minus 2. Then we have minus 2 to 3. Then we have 3 to 9. And then we have beyond 9. So what happens in this kind of questions? If at one interval something is positive, in the interval adjacent to it, it will be negative, and vice versa. So we just have to find out what will happen at x equal to, beyond x equal to 9, and then we can mark everything accordingly. If beyond x equal to 9 it is positive, then it will be negative here, negative, positive. This is how it will go on. Let us try to find it out. So if I put x as greater than 9, let's say x is 10. So you can see this will be positive, this will be positive, this will be positive, this will be positive, everything is positive. So here the graph will be positive. It's something we don't want. We want the negative parts. And as I said, it's an alternate arrangement. So 3 to 9 would automatically be negative. And you can put the values, check it out. If you put something between 3 to 9, let's say it is 5, this is positive, 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 but this will be negative. So this is, kind of very common. So we have positive, negative, positive, negative, positive. We wanted the negative ones. So we have minus 5 to minus 2 and 3 to 9. This is another way to solve the same question without having much ado. Hope you enjoyed both the solutions. Let us go on to the second question. The number of integers n that satisfy the equation n minus 60, mod n minus 60 is less than mod n minus 100, but is less than mod n minus 20 is what? All right. So to solve this question, let us do one thing. Let us solve these two first and then these two by using number line method. So n minus 60 and n minus 100. I'll just mark 60 over here, then I'll mark 100 over here. Now, what is modulus exactly? What is modulus? Modulus gives the distance from a specific point, isn't it? Distance from a specific point. So mod n minus 60, any point, it is given that mod n minus 60 is less than mod n minus 100. So we have to choose a point which is closer to 60 when compared to 100, right? A point which is closer to 60 when compared to 100. So anything which is in this interval will be closer to 60, of course. It will be close to 60. 100 is far away. Moreover, anything which is here somewhere in between would be closer to 60. This range will be 80 because 80 is exactly in the middle of 60 and 100. Anything which is beyond, which is less than 80 would be closer to 60, not to 100. That means here we have, if I solve these two, I get n is something which is less than 80, right? Less than 80. 80 won't be considered because 80 is equally away from 60 and 100. So now we have one interval, that is n is less than 80. The second one, it says mod of n minus 100 is less than mod of n minus 20. Let me mark 20 over here. All right, so same thing we'll do over here. If mod n minus 100 is less than mod n minus 20, that means we have to pick a point which is closer to 100 than 20. That means, what does that mean? That means if I take a point here in this interval, it will be of course closer to 100 because 20 is far away. And any point which goes here, here, in the between, and 60 is a point which is exactly in between 100 and 20. So anything which is greater than 60 would of course be closer to 100 than 20. So here we have this interval. All right, here we have this interval. So the interval is 62. It goes beyond, 60 to greater than 60. Anything greater than 60 would be closer to 100. For this, anything less than 80 will be following this one. Now we have to find the common area between both of them. In between this and in between this, what is common? What is common? The common part is this one. The common part is this one. So basically, how many values do we have here? 60 and 80 excluded. We have 61, 62, 63 till 79. So 61 to 79 is what we have. How many values do we have? 19 values. We'll just mark 19 and get it correct. Hope you enjoyed the solution. Let us go on to the third question. Third question says it's of logarithms. As you can see, it's a huge expression. So I'll just rewrite the expression. Well, the expression goes like this. 5 minus log of root 1 plus x at base 10 plus 4 log root of 1 minus x at base 10 is equal to log of 1 upon root 1 minus x square. I can write it like this. I can just break it in the factors 1 minus x and 1 plus x. That is kind of easy. So 1 minus x square can be broken down as 1 minus x and 1 plus x at base 10. We have to find out the value of 100x. So first we have to find out the value of x and then we can find the value of 100x. That is easy. All right. So let us do that. I can rewrite it as 5 minus log root 1 plus x at base 10 plus 4 log root 1 minus x at base 10 is equal to, how can I write this? I can write it as, look at this. Log 1 upon root 1 minus x multiplied by 1 upon root 1 plus x at base 10. At base 10. And as we know that log 1 upon something is negative. So if I say log 1 by n, it's basically minus log n. So we can just take this denominator in the numerator and put a minus sign outside. Let's do that. 5 minus log root 1 plus x base 10 plus 4 log root 1 minus x base 10 is equal to, I can write minus of log root 1 minus x at base 10. No, that is quite possible. And as you know, that log a multiplied by b is nothing but log a plus b. So I can put a log and put a plus over here, and I can write this as log root 1 minus x at base 10. I hope this is clear. So we have used two properties of logs. One is log 1 by a is minus log a. That is one thing. Other thing is log a multiplied by b is log a plus log b. So we have just used both the properties to get this. Now we'll do some shifting and everything, and let's see what happens. So if you look at both the values, we have minus log root 1 plus x, and if you open the bracket, minus log root 1 plus x here as well. So I can directly cancel them out. I can directly cancel them out, and our life will actually be very easy now. Cool. So what do we have now? We have 5 is equal to, taking this in the right hand side, I'll get minus 4. So overall I get minus 5 log of root 1 minus x at base 10. We can of course cancel out 5 and 5 from both the sides, from LHS and right and RHS, and what we are remaining with, minus 1 is equal to log of root 1 minus x base 10. Let us solve this. Then we'll get root of 1 minus x is equal to 10 to the power minus 1, or I can say 1 by 10. If I square both the sides, I get 1 minus x is equal to 1 by 100. I want to find the value of x. So it's very easy now. Solving it further, I'll get x is equal to 99 by 100. I have got the value of x now. Just look at this and process the information. You get the value of x is 99 by 100. We need to find 100x. Our answer will be 100 times this. That is 99. So it was nothing but just the basic properties of logs scattered here and there, and we get the answer. Let's move on to the next question. If r is a constant such that mod of x squared minus 4x minus 13 is equal to r has exactly 3 distinct real roots, then the value of r is what? All right. One thing should be kept in mind for this kind of questions, that we need to find the perfect squares. Like how easy our life will be if this expression was a perfect square, isn't it? So if it's not a perfect square, we can transform it into a perfect square. How? I can write this as x squared minus 4x plus 4 minus 17. Mod of this is equal to r. Why I'm doing it? Because I know that x squared minus 4x plus 4 is nothing but square of x minus 2. Writing it further, we'll get x minus 2 whole square minus 17 mod is equal to r. This is what we have obtained over here. Now there are two ways to solve this question. One way is to the conventional approach, and we'll open the mod and equate it, and the other way is graphical. So let us solve it conventionally first of all. If I open the mod, I'll get x minus 2 whole square minus 17 is equal to r, or at the same time x minus 2 whole square minus 17 is equal to minus r. The two values which we can get over here. Let us solve them. X minus 2 whole square is equal to r plus 17, or plus 17, or x minus 2 whole square is equal to 17 minus r. 17 minus r. All right. All right. So we will solve it if, and it says it has exactly three distinct real roots. All right. So if you look at this, there's a possibility, high possibility, that if this becomes zero somehow, this thing at x equal to 2, then 2 will be one of the roots, right? This will become 0 if this also becomes 0, and that will happen only when r is equal to 17. So at r is equal to 17, you will get x as 2, which is one of the roots. And we need three roots in totality. So one root we have obtained when r is equal to 17. And if r is put as 17 over here, we'll get x minus 2 whole square is 34, which will be a quadratic equation in itself. And that quadratic equation will be having a discriminant which is positive. That means we'll be getting two distinct real roots here as well, isn't it? If I expand this, x square minus 4x plus 4, putting r as 17, this is 34. So you will get x square minus 4x minus 30 is equal to 0. So this quadratic expression will be having two roots, of course, two roots, but would they be real? That we can calculate by using the discriminant, which is b square minus 4ac. So minus 4 square minus 4 times ac would actually be a positive value, isn't it? Let us look at this. Here, b is minus 4, so minus 4 square. B square, if you remember that, b square minus 4ac. If this thing is greater than or equal to 0, we have real roots. If it's greater than 0, we'll have distinct roots. If it's equal to 0, we'll have equal roots. So we can calculate this. B is minus 4, A is 1 over here, and C is minus 30. So if we calculate it, what do we get? 16 plus 120, that is 136. Of course, we can do this in mind, but just for the sake of showing it to you, I did it this way. So as you can see, discriminant is greater than 0, it's positive. That means there'll be two distinct roots for here as well. So at one value of r, that is 17, we are getting three distinct roots. One of them is 2, and other of them is, we don't need to calculate, we just know that there'll be two different roots. So the answer is option 3, that is 17. Hope you enjoyed this solution. This is such a cool solution. Now, as I said, we can have two different solutions. One is this conventional, other is graphical. Let us do the graphical one. All right. As we see, this is a quadratic expression, and of course, it will be having a parabola as a graph. So, as we did in the previous case, this is what we can get, and let us try to draw the graph of it. So, as you can see, that at x equal to 2, this value will be minus 17. At x equal to 2, value will be minus 17. So, if I consider this as 2, the graph will be something like this, where this point is nothing but minus 17, right? All right. I can write the coordinate of this 2 comma minus 17. This is what we have obtained. Now, if I put a mod, what does mod do? What does mod do? Mod calculates the distance from the origin. So whatever is negative in the graph becomes positive. So this negative part, I'll just change the ink. This negative part will become positive. How? The new graph will be this. All right. This will be the new graph. All right. And also we know that this point will be 17. It just change the direction. This is 2 comma 17. All right. We have obtained this. What next? So now the graph looks like, I'll just draw it again for the sake of simplicity. Now the graph looks like this. It goes here, then like this, and then like this. And rest everything is, we can just ignore. So this is our new graph for this expression in the left-hand side. This is equal to r. And we want to find the value of r, which will give 3 distinct real roots. I'll just change the color for that. All right. So there are various ways to do that. If r lies in this area, that is negative y. So if r lies here, then of course it would never be intersecting with this curve. That means r cannot be negative. If r is negative, there will be no solution at all. Got it? Similarly, if r is equal to the x-axis itself, this x-axis itself, in that case, it will be intersecting the curve only at 2 points, this and this. So of course, r cannot be equal to the x-axis. That means r cannot be equal to 0. Similarly, if I put r here or here, or keep on doing this, then we'll be having 1, 2, 3, 4. 1, 2, 3, 4 points like this. So and if I put r here, then I'll be getting only 2 points, 1 and 2. The best line can be drawn over here, which touches the graph at this point, 1, and just at this point, not intersecting the entire curve, just touching the curve, that is point number 2, and this is point number 3. And as we know that this has shifted, and here the value is 17, this value is 17 actually, so that means if this line can be called as r is equal to 17. So when r is equal to 17, we are getting 1, 2, and 3 roots. That was such an imaginative, such an interesting, such an innovative technique to solve the question. Let us go with option number 3. Hope you enjoy this. Tell me in the comments, because that is something I love. I'll come up with more and more techniques. Let's look at question number 5. Here, the questions of sequence and series, and there are 2 values given in quick succession, x0 and x1. And we need to find the value for x 2021. To find this, we need to first of all establish a pattern. So let's do that by finding the value for x2, x3, and so on. x0 is given as 1, x1 is given as 2, and to find the further values, we have a formula where xn plus 2 is equal to 1 plus xn plus 1 whole upon xn. So if you need to find the value for x2, I'll just put n is equal to 0 over here. If I want to find the value for x3, I can put n is equal to 1 and so on. I'll keep on doing this until I get a proper pattern. Let's do that. So to find the value for x2, I'll put n is equal to 0 over here as discussed. So we'll get 1 plus x0 plus 1, or we can say x1 directly upon x0. Let us put the values from above to given values. We'll be having 1 plus 2 whole upon 1, or we can say 3 directly. So now we have 3 values, 1, 2, and 3. Do we find the pattern now? Of course not. We'll go and try to find x3. That will be equal to, if I put n equal to 1 over here, I'll get x3. So 1 plus x2 whole upon x1 will be the value of x3. Let us try to put the values. We have 1 plus 3 whole upon 2. We'll get 4 upon 2, that is equal to 2. Now we have the pattern as 1, 2, 3, 2. Do we identify the pattern? Still not. Let's find out x4. Now it becomes easy. We don't even have to consider or think about what to put in here, because if you look at the pattern, it's 2, 1, 0, 3, 2, 1. So we'll be having 4, 3, 2. So it'll be 1 plus x3 whole upon x2, and we'll get 1 plus 2 whole upon 3, which is 1. Now I think there is some kind of pattern. 1, 2, 3, 2, 1. If we find out the value for x5, we'll of course be having a pattern for sure. So let us try to find x5 now. This will be equal to 1 plus x4 whole upon x3. We'll get 1 plus 1 whole upon 2, and here it is 1. Wow. Bingo. So we have got the pattern. The pattern is 1, 2, 3, 2, 1. Again, it starts with 1. So this will look like something like this. 1, 2, 3, 2, 1. Again, 1, 2, 3, 2, 1. 1, 2, 3, 2, 1, and so on till infinity. So once we establish the pattern, we'll try to find the value for x 2021. All right. 1, 2, 3, 2, and 1. This is what the pattern is. And I'll just put the values for x in the specific rows. So as we have seen that 1 is the value for x0, 2 is the value for x1, and so on. And we found out that x5 is the value for x5 will also be 1. So I can complete the table. Do I really need to do this? I think no. Why? Because x 2021, this value which we have to find out is basically, this value is basically 2021 is nothing but 1 more than a multiple of 5. 1 more than a multiple of 5. All right. So if you look at these values, which one is 1 more than the multiple of 5? This one is 1 more than the multiple of 5. x1, x6. Of course, if you look at the gaps, the gap is of 5 units across all the rows, right? Gap is of 5 units across all the rows. So this one, x1, is 1 more than a multiple of 5. x6, 6 is 1 more than a multiple of 5. So in this row itself, somewhere in some column, probably in 10th, 12th column, we'll get x 2021 as well. Because this is also 1 more than a multiple of 5. That means the value of x 2021 would be nothing but 2. Let us go with fourth option. The answer is 2. Hope you enjoyed this solution. It's nothing but finding a pattern, identifying the exact row and column, and then marking the answer correctly. Hope you enjoy this. Stay tuned to the space to watch out more videos like this. Thank you.